Well, welcome everybody to our Automation and Operational Excellence Decision Compass call for October 16th, 2025. We'll be talking about the future of digital twins and the role of machine builders today. And we're excited to have two presenters who are experts on this topic from Calypso, a Rockwell automation company. They will be on screen in a minute. I'm going to go through a couple intro items to start us off. They'll come on, and at the end, we'll have time for Q&A. Throughout the call, it would be helpful if you would put your questions into the chat as they arise. That will allow us to have those queued up and ready to go when it comes time for that Q&A. At that point in time, we will invite you to come off mute or come on camera if you're in an area where you're able to do so and ask your question live. That allows for a little bit of the nuance of your question to come through. If you're in a spot where you can't ask a question live on camera, I will read it from the chat, and that normally is sufficient as well. But we do like to make these seem like an actual in-person meeting. Unfortunately, we're dispersed geographically, but it's wonderful to be able to have that interaction. So please queue up your questions in the chat. And until the Q&A, if you wouldn't mind staying off camera and on mute, that helps us get a clean recording of the call for anyone who isn't able to join us live. They're able to then watch it through the member portal. Before I hand it over to Dwayne and Alex, just a couple really neat announcements for the MLC. So first up, the Manufacturing Leadership Council's Future of Manufacturing project is coming up in December in Orlando. This is an incredible program that we've been assembling. A lot of the speakers are already announced on the website, and we are announcing new speakers every day to kind of build that excitement and get everybody really jazzed up for what's promising to be a phenomenal event that will sell out. In the chat, you see a link to the website for the Future of Manufacturing Project event. We'll be talking about the future of digital leadership and how things are changing as new technologies come into the workplace and into the workforce. So I encourage you all to register for that event. If you are the main council member for your organization, that is actually included in your membership. So please register early. Make sure that you get in on the hotel before the room block closes, which takes place in early November. So we want to make sure that everybody is able to be accommodated. Next up, the Manufacturing Leadership Awards. This is our 22nd year. The award window is open for your nominations. The window closes in January, but we do encourage people to start early on the awards nominations and make sure that you have all of your information collected and in the best presentable form, so that our judges, who are experts throughout industry on manufacturing 4.0 and all of the technologies and cultural changes and all the different things that fit into manufacturing 4.0, we want you to be able to present to those judges in the best way possible. So start early, get those applications in or those nominations in by the January deadline. And we just made public on our website or on YouTube and soon on our website 2 information sessions that my colleague Penelope Brown did with information that will help you become or submit the best application that you can for those awards. So in the chat, there's a link to the awards website, and I encourage you again to start those early. Now back to the matter at hand. This is our 5th of 6 Decision Compass calls this year for this group, the Automation and Operational Excellence group. You can see in red the topics we've already discussed, and green the topic that we are discussing today. At the very end of the call, I will announce what the topic is for the December 18th call. So you're going to want to stay tuned to the very end so you can see that. It's a, you know, let's get all of the excitement and anticipation up there, and we'll do the reveal at the end here. We've had some really great calls, and this one that we're going to have today is no different. And I can't wait to hand over the microphone to Alex and to Dwayne. But before I do that, I just want to remind you, please put your questions into the chat so that we have those all queued up for the Q&A at the very end. And now, without further ado, I want to hand it over to Alex and Dwayne from Rockwell Automation so that they can run through their presentation. And again, we'll be back on at the end for Q&A. So, Dwayne, great to have you here. And Alex, see you coming on screen as well. Thank you so much, and look forward to your presentation.
Thank you, Jeff. We appreciate it.
Thank you, Jeff.
Let me end my screen share, and you guys can take over. Okay. Should be able to bring up your screen share at this point.
All right, perfect. Okay, team, can you see my screen?
Yes.
All right, perfect. So today we're going to be talking about the future of digital twin and the role of machine builders. Let me get into presentation mode. Before we begin, maybe Alex can introduce himself.
Yeah, sure. Alex Boskovich, I'm much older than what the picture says. And I am the principal, sometimes it's called like managing partner of the Calypso Digital Services for Rockwell Automation practice. Many years in digital twin arena through the years of Dassault Systems, Accenture, and the previous companies, working very much so with my with the team of the digital twin technical and functional executives, one of which is going to be presenting for the most part today, and that is Mr. Dwayne Negron. Dwayne, you could actually introduce yourself shortly as well.
Sure. I'm one of the solution architects serving underneath Alex in Digital Twin for Rockwell. I'm also our global solutions lead. So happy to present for you guys today. Shall we jump into it, Alex?
Yes, absolutely. So let's go. Let's go to the next slide. Okay, business challenges. So these are the typical business challenges, and you can read through them. And I didn't want to actually go and through each one of them and spend time on it. I would try to actually go and talk about the trends that we are seeing in many different industries from the OEM side and from the end user side in digital twin arena. So from the OEM side, the requirements that the end users are typically setting, and that has started happening in the past 2 years, I would say, at a very high pace, is that delivery of the piece of equipment, programmable equipment, that needs to be, that's always looked upon as being a piece of hardware that does a particular work on a shop floor, now needs to be followed by the digital twin of the same piece of equipment. So we've noticed that being a requirement that is very much exercised in several different industries, life science and pharmaceuticals being on top, CPG industry closely following, and then automotive, tire, and mining industries like really making the more and more influential growth in this area. So the lot of the end users are now really demanding contractually that every single piece of equipment gets followed by the digital twin of that equipment. So what does that mean for the OEMs? So the OEMs who have that technology and that can deliver it are going to be considered as a higher competitors in this field, and they're going to be selected prior to giving the opportunity to the OEMs that do not have the technology. What does that mean for the end users? It means that they're contractually going to be requesting from OEMs to deliver the digital twins. Whether they can do that or not, they can always outsource the work for sure. But or how the end user benefits from that, they get all these digital twins and they work with the integrator to create the digital lines, digital plants, and digital smart factories. So in a nutshell, everybody benefits from it. The end users are they benefiting from it because they would be able to monitor their production in digital, in real time, connecting it with the systems like the ERP, MES systems, and really executing virtual production. And OEMs benefiting from it because they would be able to do the debugging and a virtual verification of their equipment before they deliver it to the end users, making them more competitive in the field. So I would say if we go further on into this presentation, say I would ask Dwayne, who is our top SME in this area, what he has seen in his work in terms of like the considerations and biggest value drivers that that the OEMs are expecting from a digital transformation.
Yeah, from the perspective of OEMs, I think one of the biggest value drivers that they have is the idea of setting up a digital twin as a new product. The idea there is that digital twins can give their physical assets intrinsic value, but can also be sold adjacent or separately as well. This allows the OEM to have a two-pronged approach. If the client has the equipment or the machinery already installed, they can now leverage a digital twin for optimization or for troubleshooting and diagnostic. If a client does not yet have that machine, they can now acquire a digital twin to better test out or understand or begin the design process to bring in that equipment earlier. So I would say that's our primary driver. Second would be the ability for us to produce a digital twin that reduces the amount of risk or the time to value for the equipment that an OEM is producing today.
Okay. So where do you see, Dwayne, the biggest benefits to the OEM specifically when we talk about using of the digital twins?
Today, the biggest benefit is going to be in the reduction of risk for commissioning efforts.
Mhm. And so
So
we can actually go to the next slide and explore some of those if we could.
sure, we have here at a high level, design, commission, and monetize. I think we have a bit of a better slide down further that I can get to.
Okay,
Give me
that's
one
fine.
second. All right, here we go. So, Alex, would you like to talk to us or you want me to introduce the topic?
You can absolutely introduce the topic. Just go
Okay.
ahead, please.
Yeah, so the idea here, you'll see in gray, the plan, right? We've all been there. We've seen this many a time, but when a OEM and an end user are working together to deliver a piece of equipment, there is a projected plan. In that, they're going through a couple of phases: design, execution, commissioning, and controls testing. The reality that we see and that many of our end users and OEMs also experience is that commissioning time takes much longer. It has a significant ramp up time than the plan. What we try to provide with virtual commissioning is a de-risking of commissioning effort. The idea is that if you have a virtual twin of a physical machine or line, you can start accelerating efforts, specifically controls testing and operator training. You no longer have to wait for that machine to be on site or physically stood up and installed to begin these efforts. This helps reduce the risk of that commissioning effort. It also allows you to begin opportunities in optimization as well much earlier. In our experience, we've been able to help reduce commissioning time by up to 40% through digital twin implementation and increase OEE by up to 15% on
Okay.
project launch.
Okay. So from that perspective, it's like most of the projects that we have done, it's in the digital twin domain. There were more like 100 projects or very close to that number. We have been able actually to break them down into several different um, areas or several different types of digital twins. So from that perspective, like when we are talking about the types of digital twins, it's very important to understand that the definition of a digital twin is not very there's hundreds of definitions of digital twins. So
Correct.
what we think, and Dwayne, maybe you can go from the slide that talks about digital twins and what their types and how we as Rockwell Automation classify what a digital twin is and the benefits of these digital twins per se.
Understood. So from the Rockwell perspective, we break down our digital twins into 4 primary types. We have a design twin. This is usually a simulation of some sort. The benefit to end users or OEMs is going to be to augment the design process. Perhaps you have an AGV fleet that you're trying to better understand, or the interactions of a robotic arm, or the final layout of multiple machines, right? These are all simulation use cases that would fall under a design twin. Second would be a commissioning twin. This is where we are talking about virtual emulation. Previously, when we were talking about the value benefits of reducing commissioning, this is the emulation twin. Operate twins, these are going to be training experiences normally. The idea there is to help streamline operator skills and try to help them to better understand either the process or certain activities they're taking on the machinery. We see this to be a very wide domain. Sometimes they are AR and VR. Sometimes it's a little bit simpler. One unique case we're seeing with OEMs as well is actually training of controls engineers. This is kind of a hybrid use case between an emulation twin and our operate twin.
That's perfect. Like, could you talk a little bit more, transition to the next slide about what are the types of these digital twins and their major benefits and values, and especially use cases in different industries, just to bring our knowledge and perspective to the audience of what we have done and what our point of view is on the process, mechanical, control, and the material flow digital twins.
Sure. So when we take our 4 types of twin, right, we have our simulation, emulation, operation, and optimization twins. We usually have to break these down a little bit more. And so the idea is that we are generally working with a type of simulation, right? All of our digital twin types today are some level of simulation. These can break into a process simulation, a mechanical simulation, a control simulation, or material flow simulation. You'll see here a large red arrow on the bottom saying multi-model. The idea is that I could have a twin and it's going to have to incorporate multiple types of a model. For example, when I'm working on virtual commissioning and building an emulation twin, I'm usually having to do some level of controls and mechanical. What we see there is that each of these types of models have different benefits to our end users and to our OEMs. You can see how we have to be very careful about how we define our digital twins, and particularly what are the types of inputs we put into those digital twins. Am I working on an emulation twin that requires process inputs and control inputs, or material flow, as an example?
Mhm. This is really good. You touched upon, and like you talked about, the value that digital twins bring in commissioning. Could you also talk about the value of the digital twin in operations? Because the idea here is not to have a digital twin that is going to be used one time before you commission the plant and then leave it collecting dust afterwards. The idea is to keep it alive and synchronized with a physical piece of equipment. So if we talk about the value in operations for the digital twins, could you please touch upon that and give us a few pointers that you find important?
Sure. There's two perspectives there. So one side, operation twins, as we describe them, they're generally used for training. And so they are usually a use case that's coming in a second or third phase of a digital twin. The idea there is that you have some level of simulation or emulation that's been developed, and now you are leveraging that twin for additional value. You've already got through commissioning, the machine is stood up now. How do I train my operators to better leverage this machine? Or how do I have my operators use this as part of their training for other opportunities there? Um, so that's one aspect of it, right? We can use
And you
very
can you can advise the slides like by two, so we have the proper
sure.
picture what we're talking about. Thank you.
Yeah, of course. So that's one aspect of it. A second side is experimentation, right? So I have a digital twin that is now up. I have the ability to virtually represent the physical process. What comes next? Uh, in our experience in the current process, without a digital twin, you're usually waiting for line time. That line time can be extremely expensive, extremely rare to come upon, and very difficult to secure. With a digital twin, you now have the concept of virtual line time. No longer are you waiting to align with operations to run a critical test on controls code or on a new design layout, as an example, or on a new SKU. You can just run that virtually. You could run it in parallel, and you can do many efforts around that. So in our experience, we've been able to do roughly 10x the test in the same amount of time, and we're able to provide our end users or our OEMs with virtual line time. So wrapping up there, from the perspective of a digital twin, once you have this instantiated, not only can you train end users or build those experiences into your digital twin, you can also now leverage it as a virtual line time producer for any tests that are within scope today or in scope tomorrow.
Good, great. So let us introduce ourselves like to the viewership over here. If we go to the next slide, Dwayne, who's Calypso and in especially how we are being rated in terms of the digital twin production. So like Calypso is a digital twin organization within a digital organization within Rockwell Automation. As part of Calypso, we have the digital services that are delivering data science and IoT solutions. And part of that practice is the digital twin practice. So there is a significant number of more than 50 practitioners right now, and we've been building digital twins in various industries for various clients, mostly for the Fortune 1000 companies. We do have, as I have mentioned before, around 100 different projects with digital twins that we have delivered. Different industries that we delivered it to, as I mentioned before, life science is pretty strong and leading. CPG very much like immediately behind, and the other industries, automotive and tire, following up with mining. In order to do this, it's not sufficient to be alone and to have your own solution. It's super important that you can partner up with the best-in-class partners, and then being able to create a joint solutions for which we have several different partners, starting from Ansys, from DataHow, from NVIDIA, and Unity, a few other partners that are building up our offering of digital twins as well to have the higher value. And we have started as the PLM company, delivering the strategy and the solutions within the PLM lead. So, like, we learned how to run the product lifecycle management, but we were also able to apply the same principles for the digital twin lifecycle management through our CI/CD pipeline that Dwayne was one of the main people that has used the knowledge of running and managing the code in the traditional software development and to apply it to manufacturing. So if we go to the next slide, Dwayne, so we don't want to, like, when we develop these solutions, to be owned by us. This is not a good strategy for anybody. We want to deliver the solution together with the client. It's always a collaboration, but also there is the knowledge transfer that needs to happen. We would like typically to make this knowledge transfer happening within 3 projects. In the first project, Rockwell would lead the development, being shadowed by our clients. In the second project, we would be the party that would be shadowing the client that would be leading the implementation. And the third project and forward, the client would take the lead. So they would not necessarily in the long term be dependent on us. While if the client insists of using us for the future projects and that's not their core business, we would also do this type of work as well. So moving to the next slide, Dwayne, this is the work that we have done with the architecture that we have created of when we are working with clients that have multiple OEMs. So if you can explain this graph, it's a relatively big graph, but just the major points of why this is important and what value it brings to both OEMs and the end users as well.
Sure thing. Working with OEMs on digital twins today, the primary concern that we face, and this is a shared concern both of end users and each individual OEM, is IP. The idea there is that generally an end user is purchasing a piece of equipment or a line that has multiple OEMs competing in that space. So their IP is very valuable to them, and protecting that from their adjacent neighbor, even on the same line, is critical. Our experience has been that we have been able to work with OEMs directly and collaborate with them. You'll see that on this left side, to protect their IP and establish independent development environments. So in this case, we can work directly with OEM 1, OEM 2, and beyond to build their portion of a digital twin directly. In that, we have access to the specific IP of interest that we need for the first pass of the model, building it in their environment or in a shared environment between the two of us. And then we eventually progress to stage 2, or the middle of this page, where we create an integrated model. All of the original content built by each OEM is encrypted and protected, and then integrated into a single model in our environment. Once this passes all reviews and SecOps risks, we're then able to deliver that to our end user. We've had a lot of success with this approach so far with the OEMs. And essentially what we've seen is a synergy between what we consider the best practices of software engineering and cybersecOps, and also our traditional automation engineering and digital twin development.
Okay. Right. So if we can use this opportunity for the next few minutes just to run through some of the common case studies that we have um, in terms of virtual commissioning, in terms of the material movements, discrete event simulation, in terms of hyper realistic simulation with the Omniverse platform. So I would say the next 3 slides, if you can focus on these case studies, Dwayne, one
Sure.
after the other for the next few minutes, please.
Happy to. From our perspective, so our digital twins are primarily built in Emulate 3D and with some adjacent services like Omniverse. Emulate 3D at a high level can facilitate multiple personas. So in this demonstration, you can imagine we have to squeeze a lot into one screen, but this is a virtual commissioning use case. So the persona here would be an automation engineer. Because of that, you can see below some of the logic attached to the controls here. You're also going to see some of the tags and the I/O on the top right corner and additional information. You will also see a little bit of the RS links information further to the right. So a lot going on here. Generally, a developer is going to use 2 monitors to have this be a little bit more streamlined, but trying to capture it all in a PowerPoint slide. So you can imagine here we have a mechanical arm moving on a contactor line, inserting some of the parts in. You can actually see the I/O and the tags responding live to this controls emulation and all of the information on the blocks below. So in summary, we're just trying to give you a good idea of what this looks like from an automation persona. Here you'll see some of the tracks being changed live and the reaction on the machine as well.
Yeah, that's the biggest use case that we have. Virtual commissioning is a big differentiator, which makes the simulation at a higher fidelity, trustworthy to be implemented directly on the shop floor. We're getting the fidelity with virtual commissioning on 97 to 99%, which really differentiates from the use cases when only the simulation would be used. But the simulation has also its own use cases. And Dwayne, if you go to the next slide and talk about the values and benefits of what we call the simulated behavior in industrial engineering, can you just point out
Sure.
the major benefits and the when we would use simulation versus the emulation?
Yeah, so over here on the left side, you'll see the video going through what we refer to as a catalog. The idea here is that there are many parts that are interchangeable across facilities around the world, right? Conveyor belts may be unique, but they have a lot of the same properties. You can provide that same logic to quite a few other parts. So with our Emulate 3D catalog, we can click and drag these components out onto the board in front of you and immediately start testing with them. If I need another conveyor, I can drop it right in and I can get started with a simulation on trying to understand that performance. Generally, with our clients, we're building unique catalog components for repeatable assets of their physical facility. In this case, you can imagine a new type of persona, right? Before we were talking about an automation engineer. This is the same exact software, but this time you can have someone in operations or in product development leveraging this tool to start testing things out and producing results or data very quickly.
And what are the values like? And I think this video shows it perfectly. What can you monitor during the
Sure.
production run?
So we have the ability to implement C# scripting in these models. So we can produce HMIs, we can produce different types of graphs or KPI recordings live on there. You'll see a dashboard here tracking the status of a robot arm. You'll see some AGVs going on, and we're tracking KPIs attached to them. We can also demonstrate or show all kinds of information here, right? This is a digital space. With it, we can leverage a lot of our data science capabilities.
So that's really good. Well, if the look and feel of this CAD-driven digital twin is not sufficient, because I would like to create the lifelike experience, and especially for the top floor, maybe use it as a sales tool to create the really lifelike experience. What would I do with the Emulate 3D?
Sure. So in this case, we're going to give you guys a demonstration. The idea here is that there is an Emulate 3D model that's been fed into Omniverse. The two share a connector so that we can leverage some of the horsepower behind Omniverse to provide a higher fidelity rendering. So marketing is one aspect of this, right? We can create beautiful models that can equip executives to work with their clients, or OEMs to work with their end users. A second aspect of this, with this level of fidelity in our rendering, we can also start doing advanced machine vision use cases as well.
Okay.
Through Omniverse, we can do synthetic data injection for things like lighting throughout the time of day, or refraction on a cloudy piece of glass. And we can start testing our vision systems as well.
Yep, that's perfect. So it's not just for looks, there are other benefits as well. So
Correct.
absolutely. So being cognizant of time, why don't we just go and talk about the lessons that we have learned as a practice by building the digital twins? We have done a lot of work in the last 5 years, and there's certain things that we would like to share with our viewers over here, which we think are extremely important when getting into the journey of building digital twins. So, can you summarize, and
Mhm.
then if you have a little bit of time, I'm thinking we have 8 minutes, detail as much as you can the one of these, actually five of these, the lessons learned that we consider it to be of the highest importance.
Understood. So as Alex mentioned, we've delivered over 100 projects at this point, and through that, we've had a lot of lessons learned. I'm going to run over them at a high level first. I think we're going to intersect with the Q&A time very quickly, so this could be a great transition into questions if we need to. But the idea there is, number one, machine builder collaboration. So many of our digital twins are lifelike representations because they are virtual commissioning twins. Because of that, we need to involve our OEMs and get some level of IP for our development. The idea there is that either we are requesting controls code, 3D models and CAD, or engineering documents. All three of those are generally a part of our data request when building our virtual commissioning digital twins. And so we've had to get very good at collaborating with these machine builders.
Mhm.
Part of the point there from our perspective is it's not it's not as simple as just simplifying CAD or trying to black box parts of a document. There's actually quite a bit of effort that we have to do to build that partnership together and to bring in some of our best practices from other growing fields like cybersec-ops, as I alluded to earlier. Twin lifecycle management is a very big topic on our experience. The idea there is that, candidly, a digital twin can have a very short life expectancy if not properly planned for. These are hyper-realistic simulations, and they need to have a strong lifecycle management strategy behind them. Earlier in this presentation, we showed two triangles, right? The idea of developing a digital twin, upskilling an end user or an OEM in that, and helping them to stand up a team to maintain that twin over time. Of course, we're happy to help with that maintenance for as long as a client desires or wishes, but the idea is that these twins should not only stand alone and provide value well after the delivery date, but they should grow over time. There's no system that does not experience change year by year in our experience. Outcome-oriented design. In my experience, I've seen a lot of digital twin projects that we are the second iteration of. So they tried something internally, usually, end user or OEM, and they failed to get it off the ground. And not only did they not have a lifecycle management strategy behind it, but they didn't have a clear value proposition. So this is where we came up with the learning number 3. The idea is that every digital twin we produce should have a very clear and conscious value proposition behind them, and all efforts of that twin should be attached to that. In my experience personally, a digital twin can mean many different things depending on the stakeholder. It's usually the expectation, particularly from our leadership, that a digital twin should be as beautiful as possible, should have every part possible, should incorporate any and every piece of scope, right? But for us to do our due diligence, we have to understand where is the value and how do we capture that as efficiently as possible. And so there's a lot of conversation and a lot of design that goes into these efforts on the front end to help. If we could get you 80% of the value for 20% of the cost, we need a really good reason to go past that. Process model integration is another one we're seeing often. The idea here is that there are some best in industry multi-physics solutions out there today. Rather than rebuilding those efforts natively within E3D, we actually have the opportunity to just build a connector to leverage the work that's already been done or those specific models. A good use case here would be fluid modeling. And with those fluid models in particular, we can just have a full native compatibility with Emulate 3D. So you get the best of both worlds. Delivery planning, this is a complex topic, but the idea behind it is that digital twins are not easy projects to pull off. They require experience and maturity from a development team, and they require a lot of collaboration across multiple parties. And so from our perspective, that's been one of our primary lessons learned. We have to come in and do due diligence very quickly to align all of these different groups and help them to understand not only their responsibility, but our delivery plan and how we all interact or engage together.
That's perfect, Dwayne. I would like to give the audience a little bit of a longer opportunity than just 10 minutes. So I would say for each one of these points that Dwayne has mentioned, we do have the particular slides detailing the values, the benefits, the like all of it. So from my perspective, we have developed the world-class uh, delivery organization, services organization for delivering digital twins in various type of industries. Um, Dwayne and I and all the guys that work with us would be more than happy if we hear from you. And we're going to share in this presentation our contact information. So
Or I'll just jump through.
yep, yeah. So if there's anything that we could do for you, even if it's just talking about the particular problems, the ideas that you have, uh, uh, planning for this work requires, as Dwayne has mentioned, months ahead. And it's easy to not plan it properly. So whatever ideas you might have, we would be more than happy to discuss these ideas with you without any pressure on you that we have to close anything. So from our perspective, Jeff, we can conclude the part of the presentation that we had in mind, and we can answer some questions now.
Yeah, and Dwayne, you might want to leave the slides up for now, just in case we have to reference any during some of these questions. But I
Sure.
do see some in the chat. David Van Angle, if you want to kick us off, you can come off mute and on camera if
Yes,
you're able.
my camera doesn't want to work. There we go. Hi, folks. So I'm going to yield my time. We can get to my AI question at
Okay.
the end. I think I'm reading Trent and Joe and Nathan's questions, which are more apt. So I will
Okay,
yield to Trent. Trent, if you're available, would love to have you come on and ask your question. And if not, we can ask it for you.
Yeah, can you hear me okay?
Yes.
Yes.
we have you.
So kind of a two-part question. I was at the AIEG summit or 2 weeks ago, and BMW presented Catena X, which is like a digital framework, and they included digital twin. When do you think the major automotive OEMs will start requiring this to tier 1 and tier N? And then the second part of that, let me scroll down so I see what I put. How can we become more proactive with the OEMs on these future requirements? And the other concern there is, are they going to require different types? And then that puts a lot of investment on our side as a tier 1 supplier,
Sure.
at least in the framework.
Sure, and I'll answer this question because I'm located in Detroit, and the automotive entire industry is like really dear to my heart. So from the perspective when they would be asking for this, we have already seen this with the two of the Detroit's big three are already preparing to ask for this and creating the plans to communicate this with their tiers. So I would be expecting within a year or so, you should be pulled in. It is more difficult than in some other industries because there are many more suppliers. And so the whole effort of organizing this into the digital twin on their side, it is going to be a little bit more complex. But the preparations and the work that we have done for 2 out of 3 in this area, is showing us that they are clearly planning to do that anytime soon. So I would say within a year, that would be my expectations, knowing what I know and looking at their plans. And so, Dwayne, you can try to address the second part of the question, please.
Sure. I think the second question, if I understood it correctly, was how can we become more proactive with our OEMs? Was that the question?
Yes.
Yeah. What we're seeing on our side is that end users are folding in digital twin requirements into their contracts. I think this is a great first step in helping the relationship become more proactive, because what it's doing is setting you up to have easier conversations, or particularly negotiations in the long run with your OEMs around incorporating digital twin requirements. In our experience personally, uh, I've seen a huge uptick in that strategy over the last year and a half. So we went from digital twins being a pilot or a experiment to being a full requirement for all purchases. Separate to that, depending on your communication or partnership with an OEM, this is something that you guys can easily collaborate on, because there's a value benefit for both parties here. So
Sure. Yeah.
we've also seen some opportunities where we've been brought in as a digital twin SME, and we are aligning both groups, helping them to understand what they both have to gain from that, and walking them through the process of a new stage their agreement or partnership.
Just to follow up on that, like Trent is, some of the end users are creating with our help, the elaborate strategy where they're going to standardize the usage of simulation, emulation, and digital twins. So they're creating frameworks that they are going to be then imposing on the supply chain. You mentioned that there are multiple providers. Yes. Is there any particular standard, SI standard for this? No. But typically, like if there's a multi vendor solution that needs to coexist from different vendors, of course, and that needs to cooperate, there are ways and there are platforms like Unity or Omniverse, NVIDIA, that are trying to create those standards themselves, where you can use a BIM solution for the building, where you can use a multiple manufacturing or solutions, or like production twin, operations twin from the different vendors that they coexist in the same platform. So that's important to know. That's probably the industry is going in this direction, that some of the big companies are creating the playgrounds and platforms where the producers of the digital twins would be able to plug and play and communicate and collaborate.
Okay, thank you.
Great questions there, Trent. Thank you for asking those. Joseph Schimmerhorn, you're up next if you're able to come off mute.
Sure. My question was around the AGVs used in the modeling. So do you already have all the metrics loaded for a lot of the standard AGVs from typical traditional AGV providers? Or is that something that we would need to partner with our AGV provider to make sure they send you for the digital twin? And then my second part of that question is, what are the key attributes that you're looking at pulling into the digital twin from an AGV standpoint? Is it tack time and speed? Is it turning radius? Is it the width and the physical dimensions? Is it the Z coordinate or the height, the lift height, things like that? How much detail gets pulled in?
Alex, do you want to take this one or you want me to?
Let's do half and half. You go first.
Okay. All right. I think I have an answer for both sides of this question. From the E3D catalog, they do have a generic AGV that is useful across the board. With that said, partnering up, it's similar to the discussion around OEM, right? Partnering up with the vendor and getting additional detail only helps your simulation. It really comes down to the problem statement you're trying to solve, right? Going back to the analogy of that 80-20, depending on that problem statement, the catalog items within Emulate 3D will be more than enough. Going into the second side, right? You asked the question of, what are we modeling with AGVs? What is the effort there and what are we trying to pursue? I can give you a high level of what the range can be and what I've done in my personal time with Rockwell and digital twins. So I've seen high fidelity simulations. We've done some registering the exact wear of wheels on an AGV or tracks or arms and different parts to develop like a maintenance schedule and determine the predictive maintenance over years of a fleet. That would be extreme detail and high effort. On the other side, we've gone to the macro level, right? How do I organize 60 to 80 AGVs working on one level? How do they cooperate with other levels as well? And participate in a system that has a Z to it of stage 1, stage 2, stage 3, etc. The normal ask is in between the two. Generally, what I'm seeing on my side is I have a facility, I have 1 or 2 fleets moving material across that facility, and I'm trying to understand at a high level, what is the storage strategy? What is the routing strategy? What are the conflicts and collisions that I may experience? What are the intricacies of my routing logic? So it's somewhere in between the two is the normal ask, but we have gone through the extremes of like that micro simulation of where or specific product design really of an AGV or AMR. And then also to that macro side of looking at not just one or two, but multiple fleets stacked across levels of AGVs.
Yeah. So it's really important to know. Yeah, we have done with one of our major clients the complete routing optimization uh, for their AGV traffic. So that was done at a high level of fidelity. And what you have mentioned is absolutely correct. We needed to know all these parameters that you mentioned, that we needed to communicate with the AGV OEMs and get that information from them. Then we would create a digital replica of the vehicle, and then we would use multiple different optimization algorithms that we have built in to create the most optimal routing for those AGVs. So yeah, do they come pre-populated? Well, we have the AMRs. We own the AMR brand, which is called Auto Motors. For those, we would have the pre-populated behaviors. For the other ones, we would need to communicate with the vendors of that equipment and ask for pretty much the same parameters that you have mentioned to be given to us. That comes in a spec. It's not a big deal, and then we can model their behavior almost perfectly.
Okay. Appreciate it. Thank you for that detailed response.
Of course.
We have time for one more question, and there's one more in the chat. So Nathan, you are the lucky winner of the last question.
All right.
Today.
Well, I'll bring us home. I don't know how easy this one is to answer, or how short it'll be, but
Sure.
as an end user, we are working on a specification that provides requirements for digital twins and simulations for new equipment. The challenge I find is that the equipment comes from 20, 30 OEMs from all places around the globe. So certain OEMs have standardized that they have models that are built in Siemens or in Rockwell or in AnyLogic, you name it, right? So there's all these different types of modeling tools that are out there. And as an end user, I do care about being able to own the overall model, make it connect upstream and downstream, and that all the pieces work together. Looking for, I guess, thoughts around interoperability and kind of that big model of the plant, and less at the OEM kind of equipment level.
Sure. So I think I'll jump in here and we'll get some color commentary from Alex. My general recommendation to people in your position is to have a strong stance on their preferred digital twin platform and vendor. And the reason why is because it comes back to our point here of number 2, lifecycle management, right? The idea is that you can work with many different distributors or OEMs. They may each have a different definition of what a digital twin is for them. They may have a different tooling. They may have a different end vision. Who cares, right? Like you need the digital twin that works for you and your company and that you can maintain over time. Otherwise, it will not provide you with the value that you need. And so from there, you need to have a very specific stance. It's not enough to have digital twin requirements. You need to divide those into a digital twin software stack that you require, a digital twin lifecycle strategy that you require, a digital twin implementation plan or compatibility plan that is also in your requirements, right? Like my biggest coaching point with my clients, particularly around digital twin, is do not allow this to become the metaverse for you, right? There was a position in time where metaverse was very popular. A lot of OEMs were chasing it down, a lot of end users. No one could align on an understanding of what it meant. What equipment do we use? What solution? What hardware? With digital twins, we should be able to take those learnings forward and be as specific as possible on the first pass. I, as an end user, require a digital twin of my product in this technical stack that we are supporting and maintaining over time. And you will need to comply with that requirement at some level. Otherwise, it's not being fulfilled.
Yep. And it's a carrot and a stick, unfortunately, but this is in which direction this is all going. Absolutely. So it has to be driven by the OE end user side with certain level of requirements. And as of now, before we figure it out whether there's going to be a standard that's going to be used overall to specify what type of APIs every single digital twin needs to have, which we are far from it, then you would have to see which of the technology best fits your needs. And then you standardize on that technology, and then you push it down as a requirement. So that's, as of now, the best way forward. As I said, NVIDIA is trying to use multiple vendors in the same environment with various levels of success. And it could be something that is going to be very interesting in a few years from now. As of now, we haven't seen very compelling use cases. They're still stronger when there's one provider of the technology. But I would say give it a little bit of time, in a few years, maybe that things are going to be changing.
Excellent. Thank you so much for those questions. Dwayne and Alex. Dwayne, would you mind advancing just, oh, never mind.
Oh,
I was going to say
sorry.
to have your email addresses back on screen for a second.
Sure, I can put them as a screenshot as well.
Okay, great, great. But this was a wonderful conversation. Really appreciate all of the insights in the presentation, as well as the questions and your responses to those questions. Let me pull up my screen so I can share what our last Decision Compass call of the year is going to be for this group. So let's pull this up here. Okay, so as I said at the beginning, we have had 5 calls. We have one more to go. And drum roll, please. The last call will be automation strategy from beginners to advanced implementation. And that's with Schneider Electric, and that'll be December 18th. Please save that on your calendars now. You will be getting emails about it, including our Monday roll-up emails that go out almost every single Monday with details of how to register. The registration isn't even open yet. You're getting a sneak peek into what the topic is. But looking forward to seeing you all on December 18th. And before that, we hope to see you at the Future of Manufacturing Project event, the Future of Digital Leadership in Orlando at the beginning of December. And remember to start your Manufacturing Leadership Awards nominations. All of that information is available on our website. You can see the URL on the corner there, manufacturingleadershipcouncil.com. My email address is also on the screen now. Happy to answer any questions, put you in touch with the gentleman from Rockwell if you have further questions. And looking forward to seeing you all on December 18th, if not before. So thank you to our presenters, thank you to our participants, and hope to see you all soon.